This one right here, again, you're given this on the formula sheet. The formula sheet would tell you that the tangent of A is equal to opposite over adjacent. So with respect to angle A, that's the opposite side. This is the adjacent side. Alright, so it's literally just saying tangent of A equals 24 over 10, also known as 12 over 5. Literally just writing a fraction. The easiest trig problem out of all the trig problems that you could be asked. Just using our formula sheet, remembering the parts of a right triangle, and basic trig. Next one, Kevin asks Olivia what are parallel lines. Olivia responds they are lines that never intersect. So that is true. Here's a non-crappy example. Alright. So what important piece of information is missing from Olivia's response? Lines must be straight. In geometry, lines are always implied to be straight. Lines are coplanar, and it's actually that one right there. Why? This will be a good review. If you think about I'm going to draw a quick cube. Alright, that was a very fast cube. But this line right here and this line right here, these orange highlighted lines in the cube, they don't intersect, but they're non-coplanar. And we have lines that don't intersect and non-coplanar, they're known as skew. And so that's why it's not that one right there. And then this doesn't even make sense. Forming right angles, parallel lines don't form right angles. That's perpendicular lines. Alright, so that's why we can eliminate that one. Cool. Alright. Then in this one right here, line segment AC has endpoints -1, -3.5, and C is 5, -1. Point B is on line segment AC and located at 0.2, -3. What is the ratio of AB to BC? Well, we can just do one massive one massive distance formula problem. Alright, AB, again, we're just going to do this. If this is the distance formula, and then we can literally just find the distance of AB and then plug it in over that. Alright, and then we can just be careful, like say, alright, we need AB, so boom, boom. Then point B is actually going to be both on top and bottom, because we're finding length of AB and BC. Gotta make sure I use different colors. So if I can literally just plug all those points in as such. Again, doing this by yourself would probably take a little longer. Me, however, I've had tremendous amount of practice with this and done this plenty of times in my life, where I'm going to be slightly quicker at it. And again, I can plug that into Desmos. Let me see if I can just do it off screen though, because I don't really want to spend time plugging this all in. Something you would need to do is just make sure you plug it all into Desmos. And if you correctly plug this in, it should be a fourth or 0.25. Okay, just be careful, make sure you plug it in correctly, yada yada yada. Alright, this one right here, I will plug into Desmos, and it looks really hard, but if you literally just plug it in Desmos, it's easy. Alright, this is some equation of a circle. It's not in standard form. We could technically put it in standard form by hand, or we could just use Desmos. Alright, it's asking what's the radius, super hard. By doing it by hand, just boom, plug it in. Alright, that's the circle right there. And as we can see, we can count that it has a radius of 5. All right, by graphing it, and then you can count the radius and get r equals 5.